Let's have a look at this example. A man walks 3 kilometers due east and then 4 kilometers due south. Find the magnitude of his resultant displacement and direction. Okay, it has to be displacement, it cannot be distance. Why? Because we are under vector. And vector, displacement is vector, while distance is scalar. So, a man walks due east. Let me sketch it here. This is a starting point, let's assume. So, if someone walks due east, that means he's walking horizontally in the right direction. Because this to the left direction is west. So, 3 kilometers. Let this represent 3 kilometers. Okay. And then 4 kilometers due south. And that means from where it stops here, it goes towards the south. That means turns this way. But the line of 4 must be longer than the line of 3. Please take note of that. That is part of what they mark in any examination. So this is 4 kilometers. Let's represent that. Now, we have to find its resultant. So, when you are sketching, the arrow is very important. So, let me put the arrow on the line. This way, this way. The arrow represents that is vector because it shows the direction is moving. So, definitely, the man is here now. This is the starting point, this is the end point. So, we link the two together. And that is the resultant. And the resultant will move, direction will be in that form. Why? Because when you are going this way, coming this way, that means it's like you are coming from here straight, directly here. So if I want to come from, let me label it A, B, C. I am coming from A to C, and I don't want to go directly from A to C. So I can go this way, A to B, then B to C. So that is why the arrow must be A to C. So this is our resultant. And this is angle 90 here. So how do we find the resultant? We apply the formula. Now, the Fx, that means the vector falls in the direction of x, which is horizontal, is 3. And that in direction of y, which is vertical, is this, is 4. So, we sum it up and find the value. Sorry, pardon me, we are not dealing with force now, we are dealing with displacement. So I meant to say the direction of the displacement. And I'm using S to represent displacement. Alright, so the resultant displacement is 5 kilometers. How do we now find the direction? We come to the horizontal, the angle between the horizontal and the resultant. That is what we will find, and that is going to be our theta. Please take note of that, or any symbol you want to use. It is after finding this that we now know the direction. Alright, how do we find this? I have told you that tan theta. Alright. Theta has been calculated to be approximately 53.1. Now, how do we now know the direction? How do we state the direction? We come to the starting point. Let's draw a vertical line through it. Then let's extend this one to the left. So this is north, this is what? South. This is west, this side is east. Abi? So that means the direction is from south towards is this way. It has to be south something or north something. But since it's not connected, this resultant is not connected with the north, but it's connected with what? With the south. And it will be southeast. And southeast will be this angle now. That means we have to look for this angle. And this angle will be 90 minus 53.1 degree. Since the angle here is 53.1, so we subtract it from 90. So that is how we get the direction. So that will give us south 36.9 degrees east, because